All right, got a few diagrams for this lesson here for 2.1. All right, so we're going to do some graphing in terms of what makes data linear. In other words, do they line up? So this person, their base salary is $320 plus $30 per sale. So if they have 0 sales, then their salary for the week would be $320. So let's plot that point. 0, 320. Well, there's 300, 350, 400, so a little bit below the 350, a little above the 300, right around in there. Let me even make that in red so it stands out for your picture. Somewhere around in there. Then the next one, if they have another sale, that's 320 plus a sale of $30, so 350. So one sale, 350. And if they had 2 sales, that would have been $60 or $30 more than the last one. So 380. Let's just rattle off the next ones. One more sale would be 410, 440, 470. So let's plot a few of those and then see if that data lines up. So I'm going to go to the 5, 470. 5, and then go up to 450, a little higher than that. All right, and so it looks like those go in a pretty straight line. And in fact, if I highlight the others that we didn't plot, we should see those line up as well. So like the 380, 2, 380. Oh, look at that. That's right there. 3, 410. Look at that, a little above 400. So that's looking good. And the 440 as well. So this does make a line. And so if I'm looking at this pattern here, I wonder if we could come up with a formula. So S is the number of sales. P is going to represent the amount in the paycheck. So the paycheck would be P would be determined by 320 plus 30S. All right. So linear data can have a nice little formula. Let's look at this next one here. In this case, the base salary is $320, but they get $10 for the first sale, and then $20 for the second sale, $30 for the third sale. So they're getting more money for each of their sales. So salary, 0 sales would just be the $320. That's still the same. If they had 1 sale, they would have gotten $10. So that's $330 already filled in. Now, if it was 2 sales, they would get an additional $20. So $10 from the first sale and an additional $20 for that next sale. So that would be $20 more than the $330. So $350. And then $30 for the next sale. That's why that's $380, right? Because that's plus 30. Whereas that one was plus 10 and plus 20. And then the next one would be plus $40. So that would be 420 plus $50, giving you the 470. So this graph is going to look a little bit different. 0, 320 still starts the same, right around in there. And then 1, 330, so just barely more. Then 2, 350, okay. Then 3, 380. 4, 420. And then 5, 470. So if I were to try to draw a line here, if I were to connect those, it's like, oh, that's actually not a straight line in this case, is it? This one, if I follow this carefully, it really actually starts to curve upward a little bit. So it is not linear. It would not be linear. All right. Oh, that part here, that was for a different example. You'll see that in the packet online. Let's do a couple more. So this one here, we have a situation where Adam started a new job and he starts saving some money. Every month he deposits the same amount of money into his paycheck. So after 5 months, he has $175. After 8 months, he has $250. Okay, so you might think of that as like the ordered pair 5, 175, and 8, 250. So how much does he put in his savings each month? Well, if he went from 170 up to 250, that's a difference of 250 minus 175. That's a difference of $75. And that was over 3 months, though, right? The difference of 8 minus 5 would be 3 months. All right. So I think if we kind of do the math on that, how much money each month, that would be like dividing those two results, giving us $25 per month. Okay. How much money was in his account then when he started? Oh boy, how do we figure that out? Well, I guess if we was saving 25 a month and after 5 months he had 175, we can kind of just start tracking back, like fill out like a table. 5 was 175. Well, then that means 4 would have been $25 less. 3 would have been $25 less. Let's kind of keep going there. 2 would have been $25 less. 1. And then month 0, that would have been when he started his job. So how much money did he have? Well, that would have been before he started saving. So he only had $50 in his bank account at that time. So $50 at month 0 when he started. So that would be before he actually started putting extra money into his savings from working. Okay, so it looks like in this case, his amount of money that he has, let's say M for money. Oh, well, I don't want to use M for money because M is for months also. Let's do dollars. Dollars, D, equals, well, he started out with $50 plus 25 per month. Right, and that should account for all of those. So 50 that he started with, and then $25 per month after that. And in this case, it says, what do each of the variables represent? So let's be careful. You might think M is months. And yeah, that's true, but it really needs to be more specific. Because is that months, what, since he was born? No, it's actually months since he started working. So months since he started, actually I should say he started saving. Because then it's like, oh, I've been saving for 2 months, 3 months, 5 months, and so on. And D represents the amount of money, the dollars, he has. But that changes each month, right? So it really depends on a given month. So that is the dollars he has depending on month M. Oh, that was a capital M I wrote before. So now we're being more specific. All right, so let's try to graph this equation. You know, you don't really have any units on this graph like we had before, so we kind of have to do this ourselves. So let's go ahead and get our axes. All right, where that's M for the months. That's D as in dollars. And we kind of want to think, well, how many months out? Well, you know, we've got data points out from 5 months to 8 months. Let's go out to, let's say, 12 months. Okay, so let's put 12 months at the end. That means halfway. Let's see if I can get this right. This grid is a little bit small. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so it's 20 by 20. So that means halfway would be 6 months. And then halfway again. Oh, did I might have missed my halfway mark. There's 6. And then half of that would be 3. Half of that would be 9. Okay, and then we can kind of split that into thirds. Now, when you're doing your graphs on the computer, you can be a little bit more precise. I kind of got those a little bit between, but that's okay. It's just a guide. All right, and then so for how much money he has, I'm thinking 12 months later. Let's see how high we need to go on our dollars axis. So 12 months would be D equals 50 plus 25 times 12. So that would be, getting my calculator here again, 25 times 12 is 300 plus the 50 that he started, 350. So let's kind of just imagine that's going up to 500. So then halfway, I don't want to do halfway because that'd be like 250. Let's go 250, so maybe a little above would be 300, 400, there's 200, 100. So those are kind of $100 increments. And let's plot those points. 0, 50. And then let's do the 12, 350. So 1, 2, 3, 50. Somewhere about in there. And then let's see if those other points seem to match up. So like, oh, wrong button. Like 4, 150. So month 4, 150. That looks about right. 8, 250. So there's 8. That hits the graph. I'm a little off there, but not too bad. There we go. So it looks like a pretty decent graph. Let's do one more example here. Okay, so here, excuse me, we've got travel group booking a bike tour. And so notice that's $200 for the group snack pack plus $10 per bike. Okay, so it's a big upfront charge, the $200, and then just an incremental $200 per bike. So the total cost, we'll say T, is 200 plus 10B, 10 times the number of bikes. All right, so we have a kind of a similar situation where we need to draw the graph. We get our axes. It's based on the bikes and the total cost. All right, and we kind of want to get a scale, let's say a group. You know, probably 10 bikes would be enough. I mean, once the group would get awfully big after that, I think 10 would work. So then halfway would be 5, and then There we go. So that's 1 through 5, 6, 7, 8, 9, 10. I got my scale a little bit better on this picture. Now, cost-wise, well, how high up do I need to go? Well, it starts out at 200, but then it goes a little bit higher, $10 per bike, not like super steep after that. So I'm thinking if it was 10 bikes, that would be 10 times 10, right, plus the 200. So that would be 300. So the top we could max out at about 300, or maybe let's call it 400. So then halfway would be 200, 100. There's our 300. So if I plot some points here, 0 bikes, well, hey, maybe just having the snacks. No bikes. 0, 200. If you did 10 bikes, that would be 300. So we draw our point there, and we can kind of connect there. So notice in this graph here, most of the upfront cost is coming from that $200 snack pack up front. Then it's a slow incremental increase of $10 per bike after that. So it's kind of a big upfront and then just a little bit of a increase. Oh, I missed. Just a little increase, and just kind of on from there. And we'll analyze that more as we go.